Hi guys, today we're going to solve problem 8.3 from the 7th edition of Basic Principles and Calculations in Chemical Engineering by David Himmelblau and James Riggs. Well, this problem is just a simple material balance problem in drying process, no? But no matter how simple the problem is, we will try to solve it in hoping that it will help students to understand the concepts and the principles in material balance. Okay, so let us first read the question. Sludge is wet solids that results from the processing in municipal sewage systems. The sludge has to be dried before it can be composted or otherwise handled. If a sludge containing 70% water and 30% solid is passed through a dryer and the resulting product consists 25% water, how much water is evaporated per ton of sludge sent to the dryer? So first, let us draw yung process natin. No? So we have a dryer right here. Okay. And so we are feeding our sludge from here. So let's name our feed as F. Okay, so we could understand clearly kung anong stream yung pinag-uusapan natin. So, let's name our feed as F. And it says to contain 70% water. And 30% solid. Okay. And then, it is passing through the dryer. And the resulting product contains 25% water. So, yung ating product stream coming out here. So, let's name this stream as P. Okay? So, our product stream is coming out with 25% water. So, dahil drying lang ang nangyayari sa atin, so that means the remaining 75% are the solid. Now, the question is, how much water is evaporated per ton of sludge sent to the dryer? So, merong mga water na nag-evaporate. So, this will be our third stream here. And we will name this as stream D, let's say. Okay. So, since this is pure water, so this is 100% water. Okay, so our question is, how much water is evaporated per ton of sludge? Okay, so obviously our basis here will be 1 ton of sludge. Okay, pero para mas mapadali ang ating calculation, because the value is very small, let us convert this to pounds. Okay, so we know that 1 ton is equal to 2,000 pounds. Okay, so let us work with this value. Okay, so our basis is 2,000 pounds of our feed. Okay, so our F is equal to 2,000 pounds. So, para mas maging madali ang calculation natin, let me write that here we have 2,000 pounds. Okay, so ano yung mga formulas natin? First, we will do the overall material balance. So, we have F coming in is equal to those streams coming out, which is D plus P. Okay? So, as of now, meron pa lang tayong value ng F. Okay? So, one thing we need to understand about drying is that nag-evaporate lang naman is yung ating volatile component, which is water. And the amount of solid na pumasok will be the same as the amount of solid coming out. So, therefore, we can do solid balance in here, no? So, let us do solid balance. Okay, so, ang meron lang namang solid is itong feed at itong product natin. Okay, so, how much solid we have in our feed, this is equal to 30% of the feed. So we have 0.3 times the feed. And this will be equal to the amount of solid dito sa ating product dahil drying lang naman ang nangyari, no? So, there will be no solid dito sa ating stream D. Okay, so therefore, our solid sa ating product is 75% of our P. Okay, so we have here 0.75 times P. But we know the value of F. Okay, so F is equal to 2,000 pounds. So we're going to substitute that here. So we have 0.3 times 2,000 pounds is equal to 0.75 times P. So solving for this, we will have P is equal to, okay, so we have 0.3 times 2,000 is equal to divided by 0.75 is equal to 800. Okay, so we have 800 pounds of our product. Okay, so using overall balance, makukuha na natin itong value ng D. Yun naman ang kailangan nating makuha dahil we would like to know what is or how much is the water evaporated, no? So let us again do the overall material balance, no? So we have OMB and we know that F is equal to D plus P. Okay, so we're looking for D on this case. So we have D is equal to F minus P. So D is equal to our F, which is 2,000 pounds, minus our P, which is 800 pounds. So therefore, our D is equal to 2,000 minus 800, which is 1,200 pounds of water. So this is the amount of water evaporated. Okay, so this is our answer to problem 8.3 from the Basic Principles and Calculation in Chemical Engineering by Himmelblau and James Briggs.